optimizing axes when you got scattered data that you got to fit onto here. Problem if I just put my x and my y axis in central locations with no thought as to the data that I want to put on here is 0, 3, all good, 4, -1, all good. But what about this -5, 18? I can go backwards 5, but I don't have 18 squares to go up. All right, so I'm going to need to rethink. If I want to fit all 6 of these points onto my coordinate plane, I need to rethink where I'm going to put my axes. What I'm going to want to do is have an idea of how many vertical lines I have approximately. So we got 2, 4, 6, 8, 10, 12, 14, 16, 17 vertical lines, and I'm going to assume we have about 17 horizontal lines as well. Then I want to find, for my x values, what is the lowest x value up here? So just looking at the first number, the lowest one I have is -5. And what is the highest? What's the maximum? Maximum is 10 for x. So I need my x values to go from -5 up to 10. Okay? If I put my y-axis off center, over here I'll be able to go -1, 2, 3, 4, 5, and the other direction I'll also be able to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll be able to fit all of the data in my x directions. Now I'm going to ask the same questions for my y values. What is my smallest y value? Second number. My smallest y value is -15. What's my largest y value? 18. Okay, -15 and 18. So I need to get about a little bit more than 30, right, on here. So what I'm going to do is they're about equally spaced, right? I got to get a little bit more positive than negative. I'm going to put my x-axis in the center, and in the y direction, I'm going to count by 2s. 2, 4, 6, 8, 10, 12, 14. Not enough. I'm going to count by 3s. 3, 6, 9, 12, 15, 18, -3, -6, -9, -12, -15. Okay? Counting by 3s in the y direction will assure me that I can fit all my data. Okay? Now, are you allowed to count by a different thing in the x direction as you do in the y direction? Yes. Do people do it often? Not really. But for this topic, I will allow it. Okay? If you're counting by 1s, you don't have to. You may, but you don't have to label your axis. If you're counting by anything other than 1, you have to label your axis. Okay? This is how this works then. Put these 6 points on the graph. So -5, 18, go right there. 0, 3, go right there. 4, -1. Okay, -1 is a little ways down, not down to a little less than halfway to -3. 10, -15. 10, -15. 8, -11. So 8 and -11 is a little bit closer to 0 from -12. Finally, -2, 12. Backwards 2, up 12. All right, those are my scattered points in blue. Okay, it's the first thing you need to be able to do with this topic. If I give you a list of points or a table of x and y values, you need to be able to choose, arrange your X and your Y values. You need to be able to, or your X and your Y axis. You need to be able to decide, am I going to count by ones or am I going to count by more than one so that I can fit all of my information. Let's look at another set. All right, I'm looking for my lowest and my highest X values. Looks to me like 0 is the lowest, 14 is the highest X value. So I need my X axis to be able to go from 0 to 14. I'm going to put my Y axis all the way on the end. Okay, I don't need any negative numbers. All I need is the positive numbers. Ask the same question for Y. What's my smallest Y value? 13. 4. 4 looks like it's the smallest. And then my largest Y value is going to be 27. Okay? So I need to go from 4 to 27. That's 23 spaces. If I remember correctly, I only had about 17, so I'm going to count by twos. And I don't need any negative Y's either, so I'm going to put my X-axis way down at the bottom. All right? I only really need the first quadrant for this data. Okay? I'm going to count by twos in the Y direction. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Okay? Place my points on the graph. All right, so we've got all these green points scattered about on the graph representing those ordered pairs. All right, second thing we want to discuss is identifying trends, patterns, sometimes also called correlations in the ordered pairs that we have. There's three main ways that data can be correlated. It can have a positive, negative, or no correlation. All right? Positive correlation is going to mean that as X increases, Y increases. All right? As X increases, Y increases. So, or the reverse of that, as X gets smaller, Y gets smaller. Okay? So I will have dots that tend to be moving upward from left to right. If I have a positive correlation, the general pattern, the general trend will be as I move from left to right, my data is rising, my dots are rising. All right? On the other hand, negative correlation will mean the opposite. As I move from left to right, my data tends to be falling. Right? That would be a negative correlation. We're going downward as we go from left to right. Right? It doesn't have to mean you're always going downward, but mostly I'm going downward. From left to right would be a negative correlation. Okay? If there is not a clear pattern, all right? We've got dots all over the place. Seem to be going down, seem to be going up. All right, there's no clear pattern. That's when we'll say there's no correlation. All right. Now, positive and negative also get broken into the concepts of correlation being weak or being strong. A strong positive correlation, for the sake of Algebra 1, will mean that almost all of the points hug very tightly to one line. All right? I could draw one line through these red points And it would hit or at least be very close to most of them. That is a strong positive correlation. Weak positive correlation, still moving in a positive direction, but when I try to draw a line to capture most of the points, they stray a little farther away from the line. Okay? Same kind of thing when we're looking at negatives. If you have a strong negative correlation, you're going to be able to draw a negatively directed line, a line that goes down from left to right, that all of the points hug very closely to, right? And if you have points scattered about, still traveling negatively, but not sticking close to one line, this would be a weak negative correlation. You'll have, if I ask you what kind of correlation is being displayed in a scatter plot, you've got 5 basic answers: strong positive, weak positive, strong negative, weak negative, or no correlation. Putting it all together, you're going to be given a set of data in class. You're going to be given the responsibility to get that data onto a scatter plot and then describe the correlation. So we are identifying our lowest and highest x values, negative 25 to 18. I'm going to have more negatives than positives, so maybe I'll put my x-axis, my fault, my y-axis, such that I can have more negative x than positive x's. Okay, I need to get all the way up to 18. 2, 4, 6, 8, 10, 12 won't work. 3, 6, 9, 12, 15, 18. Negative 3, negative 6, negative 9, negative 12, negative 15, negative 18, negative 21, negative 24. All right, so I'll be counting by 3s there. Then in my y direction, we've got negative 50 is my lowest y. Negative 21 is my highest y. So all of my data is in negative territory. I'm going to put my x-axis way up near the top. I need to be able to get all the way down to 50. So I think I'm going to count by 4s. Put my points on there. All right, 5 points. Now, identify my trend, my correlation. I'm going generally up from left to right. It looks like I can get a line that all of these points will be very close to. So my correlation would be strong because they're all close to the line. Strong and positive because they're going upwards from left to right. All right, so that's the complete package. Take your data, make the scatter plot, identify this trend.